Okay, so everybody over here, I've logged on to Zoom. If you don't log in, I'll see if I can record this session. So what were we talking about last few sessions before the presentation of your stage one? We were talking about the relational model. Just to kind of remember what that was. We already talked about it at the point where we have the basis to be able to do the design of the database. And that's basically the entity relationship model or diagram that represents the entities in the system, how they relate to each other, and the type of relationships they have, the cardinality, the attributes. And now we want to be able to take that and represent it in a model that can be implemented into the database system. Okay. And so one way to do that, is with the relational model. And what we've been talking about up to this point with regards to the relational model is some definitions of some concepts. Some concepts that relate what we saw before with what we're going to be working on now. And so I think this is where we were at last time. We were talking about the domain. And we're mentioning that the domain is going to be all the possible values that we can have for our different for our data. We talked also about an atomic value, right? So an atomic value, we're gonna store data in atomic values. These are going to be values that can't be separated into other values. And so some examples, if we're talking about an attribute called marital status, then we can have some possibilities: married, single, divorced, separated. If we're talking about a shift or a shift for an employee's work schedule, then the days can be Monday, Tuesday, Wednesday, etc. The domain of salary is from 0 to a certain value. The domain of a salary can't be or shouldn't be negative. We talked about that as well. So the domains are going to have restrictions. And also the restrictions are going to have to do with the type of data that we're going to be storing. Okay. This is where we had left off, and we were talking about the domains of data that had to do with text. And we mentioned that whenever we have data that has to do with text or character strings, that's usually the type of data where we can have a largest margin of error. Why? Because we talked about the names, for example. We can write down a name, but depending on how we input it, even if we're using uppercase or lowercase letters, there might be a difference between, even if they sound the same, there might be a difference between them. And in this case, that can generate a problem. So we have to be very careful whenever we set a data value for text or character strings. And so questions with the domain, was the domain part clear? And this is we're gonna relate this in the end to what we already saw in programming or in programming methods. In programming methods, whenever you do a program, you have to define your variables. Your variables have to be of a certain type, right? We're going to be doing exactly the same thing here. The data that we're going to be storing, we have to identify the data of a certain type, and we have to identify or restrict the domains that we're going to be having. Okay. Remember, if you're going to step out, just ask. Okay, now another thing is that there are certain things that we've already seen that we're going to be using them again in the relational model. And it's the same thing we saw before, but we're just putting a new name to it or putting a new tag on it. So another important concept is a record. So what is a record? A record is going to be a specific set of data for a specific instance of the attributes or columns that we have in our database. Records are going to contain fields that are related. So for example, if we have, talking about students, for example, if our database has to do with the university, then we've got the student data, we have the student data that has to do with your name, your student ID, address, etc. Okay, so what would a record be? So Leo, what is your student ID? 438. And so the specific record of Leo would be student ID 438, name Leo, last name Juan, your address, etc. That would be the record that's the specific instance for Leo. Okay. And the records are basically gonna be the way we're going to be able to extract information from the data that we have in the database. A record can contain all of the columns or attributes or fields that we have in the specific instance, or some of them, depending on what we're looking for. And we can actually filter results or information to obtain certain specific records that we want. So this that we have here, okay, is a series of records. Okay, how many records do we have there? We have 4 records. Okay, this structure that we have here, we have the attributes, which is the record ID, publication date, author, and title. This example that we're given here, it kind of has to do with, what do you think that has to do with? We don't know about this example or this system that we have there, but just looking at what we have there, what is this data represent? What do you think this data is representing? I think it could be articles. Library database. It could be a library. It could be, these could be books, or these could be articles, like or like Daniel said, this could be part of the database for a library. And so we've got attributes. So for example, these might have to do with the relationship of books and authors. Okay, there's or articles and authors. We have the article and the title. Okay. We have an identifier, a publication date, the author, and the title. The columns here represent the attributes. Okay. The rows are going to represent the records, and there's going to be synonyms for things here. Remember the synonyms, and that's probably going to be a question in the exam. So the rows are going to be, we can call the data that's stored there, we can call them rows, we can call them records, and we can call them, a more technical term, we can call them tuples. Okay. The tuple is a more, it says more technical term, maybe if you're more, it's a more technical term, but it's also valid. So row, record, or tuple is the same thing, and it's going to be the specific values that we have for the attributes. Okay? So how many rows or how many records or how many tuples do we have here? We have 4. Okay. What do we notice, or what can we, out of this table that we're looking at there, what can we notice or what can we say about the records? And we're assuming that this data that we're being shown here is correct. It's reliable.
Well, for example, the ID has to be unique, right? So like we could assume it's the date. I don't think it has to be unique. Because someone could have like the thing.
You could have 2 books published on the same day, but you're mentioning something important, and there's the word unique. Are any of these 4 records the same? They are different. It's very important. Each record has to be unique. And we already talked about one thing that defines or is going to help us define the uniqueness of a record is an attribute that we're going to be calling the primary key. We could infer that the primary key here is the record ID because it's a consecutive number that's different. Why? Because we could have 2 books or 2 articles or 2 or more books or articles published on the same date. We could have 2 or more books or articles by the same author. And we could actually have 2 or more books with the same name. Okay. You're talking about calculus, for example. How many calculus books are called differential calculus by whomever? Okay. Questions up to this point? So again, it's the same thing we've been talking about, but we're defining the terms that we're going to be using in the database. And why is that? When I think what I hope that the concept of an entity and an attribute and a relationship is clear up to this point to everyone. Hope. But the thing is, when we start working with Microsoft Access, we're not going to be talking about entities, attributes, or anything like that. We're going to be talking about tables, records, and fields or columns, which is the same thing we've been talking about previously, but basically with another name. So this is kind of a summary of what we saw in the previous table. Now, what's important as well, trying to relate it to what we talked about previously about the domain, is that the table that we saw before holds different types of data. So record ID field, the data type is an integer, it's a number. At least from what we're seeing there. The publication date field is the data type date. And what were we talking about the last class about the date data type that's problematic? Well, not problematic, but we have to be mindful of. What's an issue that we can have with the date data type?
The structure.
The structure of the format. So right now, the publication date field is day, month, year. But remember that this structure isn't necessarily followed everywhere. We can have month, day, year, or in some cases, the year is at the beginning even, or sometimes the year is 4 digits or it's 2. And so we have to be very careful when we use data types to be very careful with the format. Okay. The author field is text and the title is also text. What's the difference between the author field and the title of the book or article is that the author field is text, but it has a format. In the case of the title field, it doesn't have a format. It's free text. And basically what we're going to be doing with the database system is that we're going to be going to a table like this and say, you know what, give me, I want all the books that have been published between this date and this other date. And to extract the records that comply with that. Or give me all of the books that have been published by the author Jay Carter. And it's going to extract the records that comply with that. And these are going to be the requests that we're going to be making. And what is going to be the technical term that we're going to be using for a request in a database? Somebody remember what do we call that? Remember the word that was a synonym for a question? Query. Query. So in a database, a request for data, for specific data is going to be called, yes. Our request for specific data is going to be called a query. And based on the structure of the tables and the attributes, we can extract specific records. Okay, these are the examples that were mentioned. These three examples have to do with dates. Give me everything that was before a given date, after a given date, or between two given dates. We can also do sorting operations. We can also identify a specific record and say, I want you to delete that record, or I want you to modify it. These are the basic operations that we should do. Another concept is what's called the degree. The degree is going to be the number of attributes that we have in a table. So, for example, in this one that we were talking about here, how many attributes do we have? We have 4 attributes. So we said that that table is of degree 4. Okay? So the number of attributes is going to be the degree. So this is kind of a summary of the terms and the synonyms that we're talking about. The synonyms. The first column is the technical term that we've been using, and there's some alternatives. So a relationship, or also an entity. I would say relation or / entity. Yes, it's this picture. A relation or an entity. That's what we're going to be calling a table or a file. Okay. So what's going to be happening is the following. Let's think about the university system. We had some of the entities we had were students, professors, courses, students, professors, and courses. Okay. Those 3 are 3 entities, and each of them would have a table in the database. But then students are related to courses because students take courses, right? And professors are related to courses because professors teach courses. So the relationships between students and courses and professors and courses, those relationships are also going to generate tables, as we're going to see. So an entity or a relationship, we're going to be calling that a table. Another way of calling it also, we could call it a file. By the way, we're calling it a file not because it's that the term file doesn't come from doesn't necessarily come from computing systems. It's not that it's a physical file. It's a before how were databases before we had computers? Before we had computers, how was a database? What was a database in an office?
The file cabinet?
The file cabinet. The file cabinet, correct. So basically, we don't have a database where we're going to search. I need all of the records from this date to this date. Basically, you went to a cabinet, you opened the file cabinet, you opened a drawer, and you started shifting to it. So the folders, those were the files. So that's where this comes. The specific instance is going to be called a tuple, a row, or a record. Okay, that's a specific instance. A tuple, a row, or a record. And lastly, what we call attributes is we're going to be calling those columns or fields. Okay. From now on, we're going to be using more of the terms in column 1. Which are table, row, and column. In some cases, we're going to be also talking about records and fields, but the most common is going to be what we see there on alternative 1. Okay. I'm going to give you a couple of minutes to look at this and answer the questions. So we've got a table there. And there's 5 questions there. Using the correct terminology, identify and describe the components. What are the possible domains of one of the fields there? How many records do we have? How many attributes are shown? And list some of the properties of the table. So I'm going to give you a couple of minutes to do that. Okay, so let's see here. first one, it says, using the correct terminology, identify and describe all of the components in table 7.2. Who wants to give that a shot? Let's do some volunteering here. How many people are we here in the room? 15, right, so 15 and 14. 14. Is somebody's birthday? Whose birthday is it? Luis? It's your birthday today. Oh, happy birthday. Is it today? Today? I hope you have a good, I hope you have a great day, Andres. Let's everybody sing something to Andres. Would you like to sing happy birthday?
No, but
Let's just do one verse. So happy birthday to you and many more. Okay, hope you have a great day. Oh, since it's Andres's birthday, you are going to help me out. So I think we're 15 people here. Give me a number, Andres, between 1 and 15. 8. Let's see. Leo, that's you. Okay. I have a matrix in my head where all of you have a number assigned, and that changes. And only I know the designation. So Leo, we were talking about records, fields, columns, etc. And remember that there are synonyms. So of the table that we see here, how many records do we have? We've got 4 records, correct? 1, 2, 3, 4. And that's answer to question number 3. Now, what are the fields that we have in that table?
IDs.
Exactly. So the fields that we have are going to be the columns, or what we had called the attributes. So in this case, it's the employee ID, employee name, employee initial, employee first name, and employee job code. Okay. How many attributes then? Or how many attributes do we have? There are 5. Which are the 5 fields? So we could substitute the word attribute for the word field. We could substitute the word record for the word row. And we're talking about the same thing. Okay, thank you, Leo. Give me another number between 1 and 15 that is not number 8. 5. 5 is Andres, but since it's his birthday, he's going to choose somebody else that's not number 5 or number 8. 10. Okay. Let's see. 10. It's Fernanda. 10. How many tuples do we have in that table? 4, correct. That was a trick question because we had already answered it. So we answered how many records. We have Leo answered 4, but remember the record and tuple is the same thing, so we have 4 tuples. Perfect. Let's see, Fernanda. What is the possible domain of employee job code? Just out of the information you're seeing here, what is the possible domain? From what we're seeing there, it seems that way. If we wanted to make it a little bit more broad, positive numbers, that would be one characteristic. Yeah, they're positive. And it seems like they're 2-digit numbers, so maybe there's a range, but that's that. If I were to ask, so number 5, and that could be a question in the exam. List the properties of a table. If I have a table, what are the properties of any table.
columns and rows.
Correct? First thing, right? It has to have columns, it has to have rows, or it has a specific set of attributes, a set of rows or tuples, correct? What else?
It has the, like the table information.
Well, I'm gonna go to that, what, could you repeat that?
Like it has like a category for the like title.
Well, those are the attributes or fields, that we have there. But somebody said information. That's something interesting. A table could be blank. Okay? So I could have this table, I could erase all of the data and it can be blank. So a table doesn't necessarily have to have data or information. Okay? However, the information or the data that is stored in a table, what characteristics should it have? And it has to do with the word Andres used, describing some things a couple of minutes ago. Unique. So the records have to be unique. It's very important. The records have to be unique, and that means that the records shouldn't be duplicated, or we shouldn't have any sort of duplicate data. Okay. Good. Okay, so now we're going to be talking about creating the relational model for the database. So how do we create the relational model? By the way, this is like a procedure, okay? So we're going to do a few exercises to practice the procedure, but it's basically a procedure where we just have to follow a few rules. So remember that we are basing this on the ER diagram or the analysis that we did with the ER model. So first off, we're going to define a table for each of our entities. Each of our entities is going to have a table. That's the first step. We are going to assign a name of a table according to the name of its entity. And sometimes that's very straightforward. So if we have a university system and we have a student entity, well, the table is going to be called students or students. Okay. If we have the gym fitness example that we're gonna review today, later today, hopefully, or Wednesday, then we have members as an entity. Well, then members is going to be a table. In the Sosa Corp example, we had an entity that was called department. Well, then department is going to be a table. So all of the tables we have are going to be, all the entities we have are going to be tables, and we're going to name them according to how the entity was named. The next thing we're going to do once we establish those tables is that we're going to look at the relationships, because this is very important. If we just put the tables into the database, we're really not doing anything useful with regards to how the data is being related. And that's the important thing about a database, or else we're just going to store things in a spreadsheet. And so the relationships and the cardinality, we have to analyze those once we establish the table. And there are some rules there. The other thing that we need to do, and this is I think this is going to be probably the only part of the course that's going to be a little bit of a headache for everybody, even for myself, because I really don't like the topic. I really don't like the topic. Even when I took databases and when I studied my master's, I really didn't like normalization. Normalization is really, really not fun. It is not fun. So there's something called normalization criteria. We haven't seen that topic yet. But basically normalization or normalization criteria is to just verify the structure that we have in our tables and just verify that the structure is correct. And there's some rules there that we're going to follow. That these are called normal forms, but we haven't seen that. And so this is a kind of a summary of the properties that our table should have. So in the question, the previous one was list the properties of the table, these would be them. And you mentioned a few of them. So all the tables that we generate has to have a specific name. We should have duplicate names. All of the rows should be unique. There should be no duplicate rows. The entries in the columns are atomic, meaning that whatever we put into a record in a specific field or attribute should be indivisible. That's the only unit we're going to be using or putting with regards to data there. Entries in the column have to be of the same domain and data type. So we can have, for example, in employee ID, we've got a number here that's 1, 2, 3, 4, 5, et cetera, in a consecutive. And then suddenly I write 1, 2, 3, H2, 45 or something like that. The format and the data type has to be congruent in the domain throughout the whole and complete field. And these are some examples of the data types. And you already know these data types from programming. These aren't new to you guys. It's similar to programming. We're not going to be doing operations with different data types. Okay, we're not going to be doing operations with different data types. All of our attributes or fields have to have a distinct name. So we shouldn't have a table where we have one attribute with a certain name and then another table, or on the same table, I'm sorry, with an attribute that has the same name. They have to be distinct. Number 7 and number 8 are really important. And just remember those so you guys don't get confused. In the database, the order of the columns doesn't matter. Okay, we can have an entity or a table that has 20 attributes. It doesn't matter in what order I put them. So don't focus on trying to order that, it doesn't matter. The order of the record doesn't matter. So we're just going to be putting information into the table or data into the table. If we want the data to be ordered, then we're going to do a query where I'm going to extract the data I want and I'm going to tell the query to order the data. But the data that's contained in the table or the rows don't have a particular order. So neither the columns nor the records have a particular sequence or order. Okay. Okay, questions up to this point. Okay, we'll take a 10-minute break and we'll be back. Okay, so this is kind of a summary of the properties of the table. So there might be a question at the exam. What are the properties of the table? Or mention 3 properties of the table, or 4 properties, or 2 properties. We've got them there on the screen. Okay. And all of these properties, if you notice, I'm gonna say that these are common sense things. Okay, you don't really have to think through this very deeply. Entries have to be unique. We shouldn't mix data types. Attributes should have the same data type and domain. We shouldn't do operations with different data types. Entries should be atomic. Maybe 7 and 8 are the ones that might seem weird, but those are also attributes of a table. So the sequence of the columns and rows is insignificant. It really doesn't matter. Well, why do we mention this? Because kind of in our minds, we're always going to want to try to put the primary key at the beginning, and that's fine. But it doesn't have to be that way. In our minds, we're going to try to put the data or input the data in a certain order, but once we start modifying or deleting data, then that order doesn't matter. And so the sequence isn't going to be important. The ordering of the data, that's going to come out of the queries we do. Okay. Now, when we're going to be naming attributes or fields, these are just some guidelines. And when I say guidelines, meaning these aren't rules. These are guidelines for you to follow. Okay. Why are these guidelines just to try to make the database structure congruent and homogeneous. I think I mentioned this example before. When I was many years ago, I had this student that was a very good programmer. I mean, he was an amazing programmer, but he liked anime. Coming back to the anime stuff, he liked anime. So he was an excellent programmer. He actually had a gift. But all of his variables were names from anime. So his variables were called Ranma, Pikachu, Seiya, whatever. And his programming was really good. He had a gift. But if you wanted to understand the program, the formatting and the names of the variables, that was really confusing. And so one recommendation that I always try to give you guys as engineers when you're doing a design is that try to do your design thinking about somebody else is going to implement your design, not yourself. So think about that when you do the naming of the variables, of the entities, etc., and how you structure things. Think that you are not the one that's going to implement that. You're going to give that to somebody else to implement. And something for you to think about as industrial engineers, one of the main or most important problems that we have in industry, in manufacturing, is the gap that exists between design and production or manufacturing. So somebody does a design, and we showed that with the swing. Somebody does a design according to specifications, but doesn't think about how that design is going to be manufactured or implemented. And so when the manufacturing or the production area gets that, you notice that we're asking for the product to have a hole in this place. Well, you know what, we can't do that. So we have to go back and modify the design. So whenever we're doing a design, think about the implementation. And so the way we're going to be naming things is going to be important. First is to use, yes, I mean, go ahead.
So we have to make it like integrate.
Yes, that's a good observation. I mean, that's a very good observation. We should name things. We don't have to name things with something very large. So for example, if it's a student entity or table, and we're talking about the student ID, I don't have to name the attribute student ID of the engineering students at CETIS. I can just say STD ID or something like that. The name has to be intuitive. And your comment takes me to this here. Does anybody know what a mnemonic is? It actually has to do with the intuitiveness that you mentioned. Have any of you heard the word mnemonic? You heard it. You might have heard it or seen it or read it. What is a mnemonic? By the way, it's the MN. It's forget about the M. You can pronounce it mnemonic. Yes, please. That's exactly that. A mnemonic is a very short word or phrase or short text that intuitively tells me something without having to be very large. So if I've got my table, this table here, is it clear that this table has to do with employees? Why? Because we got in the attributes for the field, we've got emp. Emp is a mnemonic. If we see the word emp, we think automatically employee. It's intuitive. Okay. So the recommendation is to use mnemonics. Usually mnemonics are very short. Depending on mnemonics are even used in programming, some programming languages. Usually a mnemonic is maybe 3 or 4 characters. 2 or 1 character isn't going to be intuitive enough. I really like that way you related it. I mean, the correct thing to think about is for it to be intuitive. If it's 1 letter or it's 2 letters, it's not going to be intuitive enough. So at least 3 letters or 4 letters would make a good mnemonic. Okay. So for example, in eventually your database that's gonna have to do with, with restaurants. Maybe you're gonna have an entity that has to do with the products or something like that, or the menu. So maybe the attributes are gonna be menu slash price, menu slash name. So menu is gonna be an attribute that if I see menu, I'm automatically gonna be thinking about the food. Well, that's a mnemonic, it's 4 letters. So between 3 and 4 letters. No less or no more. 5 isn't a mnemonic. We already said that. Oh. This is just a guideline, this second one. Ideally, use a maximum of 8 characters. There's a reason for that. There's a reason for that, and you guys are too young to maybe even have an idea what that reason is. Does anybody maybe intuitively or out of infer why we would need a short, why would we be thinking about a short name that's not more than 8 characters? Actually, not the screen. I mean, before, and we're talking about many, many decades ago when computers came out. Right now, so you have a phone, right? What do you know roughly the capacity that your phone has, in gigabytes?
200.
That might be a little, it might be a lot, but before, we could be talking about a memory that's 64 kilobytes. Okay. So right now, for you guys, talking about gigabytes is normal. And even sometimes for some storage, you're talking about terabytes, right? But imagine a world where the largest quantity is kilobytes or megabytes, right? And that's when I grew up, computers had that capacity. And so when we were talking about right now, for example, if you're going to name a file, a Word document, you can call it you can call it as, but actually as might be a mnemonic if you think about it, because we know it's the first letters of the but you could actually call it for example, for my homework tasks, I don't usually ask you for a name format. So you can literally put any name. Why? Because since you're turning it in via Blackboard, I know to turn them in. But you could actually put as the name of the file the homework task that Sosa asked me to turn in on Friday, March 25th. And I really didn't want to do it, but I did it. .pdf. You could actually name it that way, and that huge name is allowed right now because we have data types and data sizes that are huge. Actually, I don't know if you ever had to copy certain folders from your computer to another computer. If you have a folder structure in your computer that has a lot of directories and you have a very long file name, there's going to be a moment where your computer is going to say, I can't copy this. The file name is too long because of the whole extension. So before, many decades ago, we were limited by 8 characters. So if we wanted to write a file name, if we wanted to write the name of a variable or whatever, we were limited to 8 characters. So that kind of became a standard. Now, why is this also important? Because of legacy systems. You'd be surprised, or you'll be surprised when you start working in industry, that you're going to be finding legacy systems in industry and companies. What do you think a legacy system is? What do you think a legacy system is? So you're in an organization and you find, and you're going to be implementing whatever type of system. It doesn't necessarily have to be an information system, but there's a legacy system. Like, what do you think a legacy system is? That's a good definition, and the key words about your definition is it's a system that was developed before and stayed. It's still operational. I'm going to add something to that. It's something that was before, but that still exists. So You're gonna find a lot of legacy systems that were developed before certain current systems. And this isn't that uncommon. And we're not just talking about information systems. You might be looking at a production line, and the production line has some sort of automation in it. And that's a very old automation with very old software. Why hasn't it been updated? Why?
Works and it's not.
It works. And if you are the boss of the company, and somebody and suddenly you hire a SETIS engineering student from the global program as an intern, and that student has a lot of energy and says, you know what, I noticed that there's a legacy system. This is very old. Let's change it to a new system of something that I've seen in class. What's the first thing that the boss is going to ask you?
Why should I go work?
Why? Why? And maybe, again, you're a SETIS engineering student, you got a lot of energy and say, well, why? Because you want to be up to date. It's old. What you're using is old. What's going to be the next, probably the next question? Actually, the first question should have been this one, but what would be the next question?
How much?
How much? Well, we're gonna have to buy some licenses, we're gonna have to, well, maybe we're gonna spend maybe $200,000, maybe $1 million to do it. And you're gonna go back to the first question, why? If it's working, why should I update it? Because remember that if I want to change the system, I'm probably gonna have to stop the current system while I change it, right? You shouldn't change a tire while the car is moving, right? And so that's why legacy systems exist. It's because they're there and they're working. And it's curious that you're gonna find a lot of companies that have a lot of legacy systems. That's why when we were talking about your final projects, I asked if there was already a system implemented. Because it's not uncommon to find in an organization that they've got a system implemented with very, very old, software or technologies. And so we might find legacy systems that use other standards, and so we need to keep that in mind. So the maximum 8 characters, that's a guideline. It's not a rule. So meaning I'm not gonna grade that in anything that you use more than 8 characters. I might make observations if you put names on it. If you like the anime that you were watching, Marco, and suddenly you name everything as the names of that anime, I might make an observation that that's not ideal, but these are guidelines. Define structures and standards, meaning that, for example, in this table, all of the attributes start with M. That's a structure and a standard. So you're going to say all of the attributes are going to start with a mnemonic. And then I'm going to have an underscore and something else or whatever you define. So define a structure, a nomenclature that you're going to be using.
Actually, you used to do that for informatics. We used to do spreadsheets on Excel, and I did a work on. I did the whole menu of worker adding. So I did all of them, and it was, but it helped me a lot to organize it, and like I got really good ranking on that. Like all the people were writing a complete thing of things, and then
You define a structure and a nomenclature. And again, that's thinking for it to be understandable for other people. Okay. And also to try to optimize certain things. So defining the structure and the certain standards that you're going to be using would be good. So for example, if we got a table that's called student, then I might use I might use ST. ST, I just mentioned the mnemonic should be 3 characters. That should be ST. That should be STP. ST might be too short. As the first part, then the structure is underscore ID. ST name, for example, for the name, the phone, ST tel. And so there's a structure there. Again, I'm not saying that that needs to be the structure. I'm just saying that you should define the structure and the method. And you're gonna do that for your final project. That's part of what you're gonna be defining in stage 3 and 4. 3, it's the design part, and 4, you should be ready to be able to implement it into the database. Employee, we already mentioned, so employee ID and the other thing that we're not used to doing, that I'm going to ask you to do in every exercise, and also when we work with Microsoft Access, I'm going to be asking you to add a description to each of the elements that you're adding. So when you did programming in programming, and you did a program and you defined variables, was there a table that accompanied your program that explained what each variable was? Yes or no? Who did that? It's not common for you to do that, right? You do your program and then you've got another document that says I is an incremental variable that I'm using for a cycle that does this. Then this does that. And so that's a cross-reference that describes what each thing is. That's something that I'm going to ask you to do. And that is something that I'm going to be very mindful of checking in your database and when we implement it in Microsoft Access. Whenever there's a field that says description, I want that field filled in. You're going to comment.
I was going to say something, but just about what you asked about the.
Oh, go ahead.
Some activities you were right now, not in a separate document, but right in the program, like the apostrophes or.
You annotated it, you make comments. That's important. We don't usually do that, but again, that's thinking that somebody else is going to read it and be able to understand. Okay. So yeah, the comments as well, and sometimes in the comments to make those descriptions. But I am going to ask you to do that. Okay, questions up to this point? Okay. Yes, go ahead.
I think something is computed, but for other reasons. For example, I saw like meme on Facebook, leak plátano, leak fresa. So some people thought it was licenciado plátano.
Oh, well, yeah, that's an interesting observation. That's an interesting observation. I mean, you have to be careful as much as you can be, because it's really complicated to be. It's really complicated to think forward to those situations. So if you're talking about LIC, L-I-C, that might mean licenciado, but somebody else might read it and might think it's a mnemonic for lick. As much as possible, you should verify that. Maybe out of common sense, try not to use mnemonics that you know might be complicated words in a certain language. Okay.
Not use STD.
Well, STD, that's a good observation. STD might mean something else in English as well. So you should be thinking about that, I know, but it's really complicated for you to think about all of the possibilities, because you don't know if that's going to be checked by somebody in Iran, and maybe in that country that word means something and you didn't think about that. You should try to think about that, but as much as possible, but don't worry if you don't consider everything. Yes. Yes. Yeah, there was actually an example we were talking about relating to that, but I remember I'll tell you guys. But yeah, the naming and how we structure that has to be important, because something might sound some way, but mean something completely different. Did I tell you guys the anecdote about the human being? One things that I usually do, not just myself, many professors, coordinators. Whenever a student has to, whenever you guys are gonna be having to do, you're gonna go be wanting to go in an exchange program, or you're gonna apply to a scholarship or whatever, you ask us for letters of recommendation or whatever. And usually students ask me to review their letters. If you're gonna go to an exchange program or program, they might ask you for what's called a letter of intent. That's a letter where you explain why you want to participate. And usually students send us their letter, oh, Professor, can you please check it just to see if it's okay, or you have any recommendations. So I had this student that was gonna go on I think it was an exchange program to a university in Europe. And so he was writing his essay that why he wanted to go. So I want to go to this university. First, I like the country. I like the university because of this, and that. I think the experience is going to be very important to me because it's going to help me be an integral human. It's going to contribute to me being an integral human being. That makes sense, right? It's like we said in Spanish, un ser humano integral, right? It makes sense. But he had not written being. He had not written B-E-I-N-G. He had written B-E-A-N. A-E-A-N. No, not Bain. Bean. Like a frijol. So he hadn't written human being. I'm gonna, because you guys are thinking, oh, autocorrect. No. This was before autocorrect. This was at a time where the computer wasn't going to correct those things for you. If you made a mistake, it was because you made a mistake. You couldn't blame autocorrect. So basically, the Mexican student was telling the European university that he wanted to go over there to be a more integral frijol humano. Okay. So again, being and being sound the same. We have to be mindful of that. We can't be mindful of everything, but we'll try. I was this close to not correcting it because I found it so funny, but I actually told me, no, you need to change. You need to change this in the essay or else you might not get accepted. And he actually did get accepted. So here are some rules we're going to follow with regards to tables based on cardinality. So cardinality. Remember that we have basically three types of cardinality: one-to-one, one-to-many, and many-to-many. And each of our entities was related to other entities and had a cardinality associated to it. Remember that if I have entities that aren't related, then there's something wrong. All entities have to be somehow related. And there has to be a cardinality associated. So based upon the cardinality, we're going to follow those three rules. So remember, the first rule is we're going to establish a table for each entity. The next thing we're going to verify is each of the cardinalities of the relationships. So if I have two entities that have a relationship of one-to-one, then there's two things I can do. I can join them into one table. I can just merge them if I want. That's not necessarily what I would recommend. The other thing I can do is that I just move the primary key of one entity to the other. Okay. So let me give you an example. Let's say that I've got the entity is a person. Okay. And another entity is a passport. Is it clear that it's a one-to-one relationship? Right? A person can only have one passport. The passport can only be associated to one person. So I've got I'm going to have two tables. I'm going to have a person table with all of the information of the person, and I'm going to have a passport table with all the information of the passport. Is that correct? Mm-hmm. So, and let's say that the passport has a passport number. So in that relationship that's one-to-one, the only thing I need to do in the relational model is grab the ID of the passport and put it into the person table. That makes sense? So for example, let's say, Alejandro, you are one of the records. So you have, let's say that we're gonna identify you by your CURP, okay? So what is your CURP, Alejandro? You don't know your CURP by number?
But I have.
I'm joking. SOLJ HBCS, no, SOLJ 750222 HBCS PR01. That's mine.
I mean, but it's a format, right?
It's a format, actually, it's a format. You can deduce your CURP because of the format.
I think you use it too, to remember that we.
Yeah, the first is your name, your last name, but there's certain considerations there because certain last names can't be represented and there's things
I
there.
have an X on my.
Yeah, that's because you're Aime Valenzuela and Guerrero. There are certain combinations. So for example, in mine, it's Sosa, so it's S-O. Lopez, so it's L, and then J, S-O-L-J. But there's certain combinations that can't be created or generate confusion. So in your case, it would be Aime Valenzuela.
It would be
Gonzalo.
A.
Yeah, so some letters would be repeated and they would overlap with your name. So in some cases, they have to put an X there. And an X or something like that? No. I have this sort of, I don't know what to call that memory. So I know my CURP, I know my credit card numbers, I know all that. But I forget people's birthdays. So I know my CURP, but I forget birthdays and stuff and other things. But Alejandro, let's say that we identify you with, the fields are gonna be your CURP, your name, maybe your address, and your telephone number. Those are the attributes or the fields of person. And Alejandro has a record there. And then there are the attributes of passports. So there's a passport number associated to your name. That's over here. So the only thing we're going to do is that in your person table, I'm just going to add the passport number as another one of your attributes. That makes sense, right? I don't have to, because why? Because Alejandro is only going to have one passport number. So with a relationship that's one-to-one, the only thing I need to do is grab the primary key of the other entity and just add it to the well, I can move either one. Okay, I can move either one. So I could move your passport number to your person, or I can move your CURP to the passport number. Either one would work and would still uniquely identify. So when there's a one-to-one relationship, we're only going to do that. Or we could just join both of them if we want into one larger table. By the way, we're going to be doing a series of exercises of these so we can practice. If I have a one-to-n relationship, so in the one-to-one, I can add the primary keys however I want. Okay. In a one-to-n relationship, I'm going to grab the primary key of the one side and put it on the end side. I'm going to add it there. So let's remember. So for example, in the Sosa Corp, there were employees and there were dependents. Remember? And remember that dependents was a weak entity. So an employee can have many dependents, but a dependent can only be associated to one employee. So it's a one-to-n relationship. So what would I do? I would grab the employee number and add that to the dependent. Okay, the primary key of the employee, which is employee ID, I would add that to the dependent. Okay, so if a dependent is Sara Michelle Sosa Aguilar, out of a weak entity that doesn't have an ID, then I would just associate that to 72263, which is my employee number, and that resolves that relationship. Okay. So again, a one-to-n relationship, I'm just going to grab the primary key of the one and put it on the n side. The ones that are a bit of a headache are the n-to-m. If I have an n-to-m relationship, in an n-to-m relationship, I need to create a new table. A many-to-many relationship requires a new table where I basically grab the primary keys of the other two tables or entities and join them as a new primary key or what's called a composite primary key in the new table that's generated. And in that new table, I can add other attributes that might be of interest. Okay, I can add as many as I want. Another way of looking at it is that imagine that when I have a many-to-many relationship, I'm going to create a new entity that is I'm going to create a new entity that is the relationship. And that entity is going to be defined, or the records in that entity are going to be defined or uniquely identified by the combination of primary keys. So, for example, let's see what a many-to-many relationship we had in the case of in the case of the social corp, we have an organization that had employees and projects. So an employee can work on many projects, and a project can be worked on by many employees. So how I'm going to resolve that, I'm going to create a new table that's called projects employees, and running around the project ID and the employee ID, and those are going to be a combination of a new primary. And those are the three rules we're going to be following. Those are going to be the three rules that we're going to be following.